Hello, Riley. As promised, I'm up early on a Saturday morning, so let's tackle part D and get you going on this. Again, I said in my email, you can't really bring down your mark that much, so I think you're stressing a little bit too much. A 15% exam is you've got to you've got to change your mark by at least 10%. Just to change your percent by 1 for your final mark, right? So, if you multiply your mark right now by decimal 85, that's what you would have if you got 0 on your exam. And then anything that you get on your final exam, you would look at that as a mark out of 15. And, so like let's say if you had 90, and that counts for 85%, then that's 74.5 now. So that's the lowest mark you could get if you got 0 on your exam. And then anything that you get out of 15% on your final exam would be, added onto that. So let's say that you got 12 out of 15 on your exam. Sorry, that doesn't go there. That's 80%, right? So if you went down to 80%, that's worth 15% of your mark. That gives you 12 marks on your exam, and that gives you 76.5, 86.5, sorry. So that would be rounded off to 87. That only changes your mark by about 3%, right? If I did that correctly. 12 out of 15 is 4 out of 5 is 80%, yeah. Okay, so you really can't change your mark that much, and so don't stress about that. Oh, I see what I did wrong. I knew something was wrong. That's a 76, not a 74. So that's an 88.5. So that would be rounded off to an 89, and that's only 1% different than the 90 you started with, right? You went down 10% on your exam. So I don't want you to worry about that and over stress on that. So let's look at these questions. The probability of success on the second flip and so on for the coins. What you want to do is start by either making a tree diagram, or in this case it's probably easier to just make a list of the 8 possible outcomes when you're flipping a coin 3 times. There's 8 of them. Let me just write them out here for you. I would have sped things up if I had written them out before. Sorry, I don't want that. I want H and TT. No, I got that one. What am I missing? Sorry, it's early. H, T, H, T, H, 2, 4, 6, 8 of them. And so when they say success on the first 3 flips, this question is worded terribly. Oh, sorry, I missed part A. What's the probability of success on the second flip? So we're just looking at the middle letter in each of these and counting up how many are a success, which means tails, right? So 4 of them are, and there's a total of 8, so that's just probability of 1 over 2, okay? The probability of successes on the first 3 flips, that should just be on all 3 flips when they worded it really badly. On all 3 flips, there's only one of those, or do they mean, no, sorry, that's C. See how badly they worded it? The probability of success is it should be of the first of 3 flips, and so it's just the first letter you're looking at, so it's the same as the question above, which is just half of them are tails on the first flip, and half of them are heads. So for C, the probability that there'll be exactly 3 successes, that's the TTT. There's only one of those out of the 8, so that's your probability there, okay? So a certain surgical operation on the elbow is known to be successful 75% of the time. 10 people have this operation. What's the probability that the operation will be successful in all 10 cases? So we want 10 to choose 10 here. And then we want success to happen 10 times and failure to happen 0 times. So if you just multiply that out, I think you get, I can't remember what you got. I think it's like 0.563 or something like that. that's the probability of all 10 patients having a successful operation. For part B, the probability of at least one of the operations being unsuccessful. When they say at least, that's kind of a keyword that tells you that you want to do the 1 minus on a question. Because at least means 1 or 2 or 3 or 4 or 5 or 6, all the way up to 10. You don't want to do 9 calculations and add them all together, which you could do, but it's just a lot of work. It's easier if you do 1 minus the probability of 0, because if it's not 0, it's at least 1. I hope that makes sense. So we found the probability of 0 here, right? So if you take that answer and go 1 minus that answer, then you'll get the probability of at least 1 not being successful. And then for question 3, now there's an easy way to do this and a complicated way to do this. I'm just going to do it the easy way right now. In the first case, the percent of the shots that will land more than 8 from the center. So we're looking at a normal curve with 5 as your average. And then we have 8 obviously over to the right. And what they're asking for is the area under the curve to the right of that value. So what we're going to do is set it up as a z-score, where we take our raw value 8 and we minus the mean, which is 5, and we're dividing by the SD. That's 3 over 2, which is 1.5. So if you go to the z-score chart and you look that value up, that's not the value we want, because z-score charts always give us this value to the left of the line, and we want this value to the right of the line this time because they said greater than, which is not very frequent. They don't do that a whole lot, but you got to watch the words and make sure you're answering the question when they do. So what we do is we take the z-score from the chart, and we're just going to set it up now as a 1 minus, because we want the other portion of the curve, not the portion they're giving us. They're giving us this, and we want this. So we just do 1 minus whatever the z-score value, the probability is for the z-score of 1.5 in the chart. And I don't have the chart in front of me, which is why I'm not writing the value in there. I'll let you look that up on the z-score chart. And the z-score chart is embedded into the exam, so you don't need to have one. And you don't need formula sheets, because they're the formulas that you're allowed to be given are also embedded into each question. You just click on the little link there that says formula sheet. Now, part B, what percent of the archer's shots will land at the target center? So we're assuming that that's 0 centimeters from the center. That should make sense, I hope. And so the easy way to do this without complicating things too much, because we're so close to your exam and I know you're stressed, is to just use 0 as our raw value. That's going to give us negative 5 over 2, which is negative 2.5. Now, the reason I say easiest way is that sometimes people will, like for values that are right on, you're supposed to go 0.5 before and 0.5 after the value and calculate it. The negative 2.5 is such a small z-score anyway, like what happens on your normal curve when we look at it, is that 2.5, when z equals negative 2.5, you're way down here in the critical region, like there's almost no area under the curve left at negative 2.5, because at 2 for a z-score, that means you're 2 standard deviations from the mean. You're already looking at 95% of the population covered at the z-score of 2. So now we have just 2.5% left in each tail, and only a part of that. So it's going to be a really small percentage. So even if we did the 0.5 before and the 0.5 after the 0, it's not going to change our answer too much. So we're okay to just take the easy way out here and go to the z-score chart and look up the probability for a z-score of negative 2.5. And that's how you do those. And so the exam is not as hard as this, I promise. You just have to look up z-scores and stuff and calculate really simple z-scores when it comes to questions like this. Most people are doing very, very well on the exam. And so the last thing you need to do is stress about it this weekend. You're doing just fine in the course. I think maybe you got a bit behind in the last couple of units, but your mark is going to hold up, and I don't think that you need to worry, okay?